Today's session, we're going to look at homeostasis, and more specifically, we're going to look at how the body tries to maintain homeostasis in relation to core temperature. So as you may or may not be aware, the body is always trying to maintain a state of constant equilibrium. And certain physiological and sometimes hormonal measures are acted upon to try and maintain that all the time. So when our body temperature rises through things like exercise, we have various different things occur in order to try and maintain a constant core temperature of about 37.5 degrees. One of those things that happens is sweating. So we sweat as a result to try and cool ourselves down, to try and maintain that core body temperature. So what we're going to do today is we're going to have some people exercise in groups, and so they're going to do a 30-minute performance test. So you're going to cycle for 30 minutes, and you're going to cycle as far as you can in 30 minutes. What we're actually going to measure are two different things. So we're going to measure the sweat rate of our individuals, so how much they sweat in that half an hour period. And we're also going to measure the composition of that individual sweat as well. And when I talk about composition, I'm mainly talking about the sodium content. So how much sodium comes from that sweat. So why are we interested in measuring the amount of sweat that someone, or the amount of how much someone perspires in that 30-minute cycling test? Why are we interested in someone's sweat rate? Or why is a sports scientist interested in that? Any ideas?
Sodium content?
So the sodium content from the composition, so from sweat rate, if we know how much somebody sweats, we can know how much fluid we need to replenish. Okay, so things like dehydration can be caused from excessive sweating without adequate fluid consumption. So if we know someone, let's say they sweat 1.5 litres per hour, we know we have to give them 1.5 litres to maintain their fluid balance. In relation to sodium concentrations, when we sweat, we also sweat out sodium. And sodium is an important mineral in helping with water retention. If we sweat too much sodium, that can have negative effects on performance as well. The amount of sodium an individual sweats will vary. So there's quite a big variance in how much sodium someone sweats. So when, I'm sure you've all had a sports drink before, and it may say on it has like electrolytes in it, have a certain amount of sodium content. So if we know, again, how much sodium is in someone's sweat, the sweat composition of their sweat, we can then tailor a sort of bespoke sports drink for that individual, which ensures that they're not losing too much sodium and having those sort of poor performance effects. Okay? So we'll do this lab in two sections. The first half of the lab, I'm going to ask you to actually collect the data, do the cycling, and then I'm going to come back together and I'm going to show you how to do the analysis for the sodium composition. So, if you go to the third page of your handout, let's start the first 2 pages for the time being. If you look at table 2, during the 30-minute performance test, you're going to collect 3 different things. So on these watt bikes, if you're not sure how to use them, I'll come around and individually show you how to use them, but some of you may be familiar with how to use them. You're going to record distance every 5 minutes. So every 5 minutes of the exercise, we're going to look at the distance in meters that person has cycled. We're looking at this so we can look at things like pacing strategies. So if someone goes all out and then they sort of settle off, or they're going really slowly, that might explain some of their sweat results at the end. We're also going to measure heart rate. That will give us an idea of intensity and how hard that person's finding the exercise. And we're also going to measure RPE, or rating of perceived exertion. So there'll be some sheets. It will be 6 to 20, and the person every 5 minutes you're going to ask them how hard they're finding the exercise. Okay, so 6 being that it's really easy, so like standing around here would say is a 6. 20 being I need some exercise in the next sort of 10 seconds or so, I'm absolutely sort of whacked. Okay. So, while your person is exercising, they will need to wear a mask. Okay, so you'll all be familiar with these masks from the previous lab session. These filters are slightly different. They have like a squashed end and they have a circular end. The circular end goes into the mouthpiece. So I won't explain that too much. Something new for today's lab, you're going to wear these gauze plasters. So these gauze plasters are how we collect the sweat to work out sweat composition. So I'll just show you what these look like. So you simply take off the edge, and inside is a plaster. Okay? So plaster inside, so that's where the gauze, that's where the sweat is going to gather. You peel the back off like you would do with a regular plaster, and on the front there is like a paper almost border around it. At the bottom end of the paper there is a little almost like an indentation in it, and you can peel that off once it is on the person's skin. Okay? So these are positioned, one on the forehead and one on the upper back, okay, between the shoulder blades. If someone is wearing like moisturiser or something like that, that will need to be wiped off with some kind of Alco-Sol or something like that before you put this on. Okay? So you're going to do that to start with before the person starts exercising. The exercise will consist of a 5-minute participant-led warm-up. So that 5 minutes they can go on the bikes, they can make sure they're happy with the gearing system, make sure the seat is in the right height for them. Then stop that and then they do the 30-minute performance test. So you time that and record those 3 things that I mentioned to you: heart rate, RPE and distance covered. The participants, before they begin, will need to fill in a health screen and an informed consent, which can be found on the desk over here. Okay? They will also need, to get our sweat rate composition, they will need to go into the shower room, which is positioned just behind us, or just by that door over there. There's some very sensitive scales in there, so they need to weigh themselves wearing minimal clothing and report back what that weight was. Okay? And that can go on table 3 of your handouts. Because I imagine people exercising are going to exercise quite hard, you can drink throughout the exercise. Okay? But the people, the experimenters, will need to weigh the amount of water that is in the cup before the person's drunk anything. And if they say drink half a cup, you need to weigh it again, and that is used in your calculations of working out sweat rates. Okay? In the calculation, you will also notice it says that to work out sweat loss, body mass pre, take away body mass post, which is quite straightforward, plus the weight of the drink, so how much they drank. So this is just water, there's a water fountain over there, don't drink anything else other than water. It also says minus the weight of any urine or feces produced. Okay, so I'm not really in the mood to measure any urine or feces this morning. So, participants, if you can go to the toilet prior to doing the exercise, then we can ignore that urine and feces. But if you are measuring sweat rate or anything like this over a day or over a long period of time, that would need to be considered. That's an important thing to mention. Okay? Obviously wearing gloves, there's some tweezers on the side. Take the sweat patch and sweat side down, put it into the syringe. Okay? Make sense? Yeah. You put the cap onto the syringe here. Then take one of these universal containers and you squeeze out sweat into the container. Okay? That's it. Yeah, you've got the sweat in tubes. And then if you try and work out sweat rate, so that calculation.
So just put out
Total
the
sweat loss.
times by
You've got
2
the
because
information
that's
actually
times
fine.
So we
Then I'll run
figure
through
out
how you
sweat loss
analyse
and then
that
do
sweat.
sweat loss
You-
times the
yeah, times 2 something.
So you put them separate so you know which one's which. That's
At least one of these tubes, I won't say full with sweat, but it should have some sweat in one of these tubes. If you've got two from the back and the forehead that are filled adequately, great. If you've only got one, that's not a problem. Okay? So, what you need to do is collect one of these pipettes, which should be on the table. So if you've never used one of these before, at the side it will have a number on it. Okay, so this one says 500. So on yours, make sure yours also say 500. If they don't, you can turn the top and it will go up and down. So this is 500 microlitres, so that's half a milliliter. Okay, that's what we want to use. The first thing you do is get one of these tips from the cups that are on your tables and put it firmly onto the bottom of your pipette. How these pipettes work is they have a almost double suppression. So when you put your thumb on the top, you press downwards, there's like a resistance you feel, the first resistance. If you press a bit harder, there's a second resistance, it goes a little bit further into there. So what you want to do is take your tube with your sweat in. Outside of the tube, press down to the first resistance. Okay, so not to the second one, to the first resistance. Go into your tube with the sweat in, go to the bottom of the tube, and then gently, slowly release the button at the top. Then you should have half a mil of sweat into your pipette tip. Okay? If you've got lots of bubbles and things in there, best thing to do, go to the second resistance and take it all out, and then go again. So in the air, to the first resistance, into the solution, let go gently, making sure you've got no bubbles in your tip. Once you're happy that you've got full sort of quota of sweat in your pipette tip, then you'll have another container that is labelled 19.5 millilitres distilled water. Take the top off that container and then submerge your tip into the water and go down to the second resistance to make sure all your sweat is out. To ensure that it all comes out, what you can do is go down to the second resistance, then you can actually take up some of the water and go down again, so you flush out what's actually in the tip. Okay? Once that's all in there, so you'll have 20 mils of solution, 19.5 water and 0.5 your sweat, then shake that container up to make sure it's mixed. And if you can just pass me that thing on the table there, conductivity meter. Then everyone should have one of these conductivity meters. With these, you press the on button and it goes through a calibration before you start. When it says 0 and US, that's 0 microsiemens. That's what we're going to measure initially. Take the bottom off and then submerge the conductivity meter into your solution. And you can leave it there for maybe 5 to 10 seconds until the number is stabilised, and then that's the number you need to record. So you can record that in your handouts in table 1, and that can also be used in the calculations on the following page. So there's calculations for forehead, calculations for upper back. They're the same calculations, so you put your value from the conductivity meter at the top, and then you just work your way through the calculations until you get a sodium chloride value at the bottom. Okay? Then that value can also be added to table 1. If you've got any questions, just let me know. Okay? Any questions? No? Okay, off you go.